Okay, this is another in my series of everybody's favorite topic in chemistry, stoichiometry, and today we're going to do moles to grams. So we're going to be given the number of moles of one of the compounds in our chemical equation, and then we're going to figure out how many grams of the other reactants and the products we're going to produce. Okay, so let's go ahead and let's get started. Okay, you can see we have a combustion of ethylene, C2H4, and we've been given that we want to produce 0.65 moles of CO2, and we want to figure out how many grams, and how many grams of water. So how many grams of ethylene and oxygen are we going to need, and how many grams of water are we also going to produce? So as you know, our chemical equation gives us a molar relationship. It's not a gram or a mass relationship. So the equation says here that 1 mole of ethylene plus 3 moles of oxygen will yield 2 moles of carbon dioxide and 2 moles of water. Okay, you can think of it as atoms, molecules. I tend to always think of it as moles. Okay, so there are 3 steps to every, not every stoichiometry problem, but there are 3 common steps we use for stoichiometry. Sometimes we use all 3 and sometimes we don't, but the 3 are, first of all, we're going to convert from grams to moles. Now we've been actually given the moles, so we don't need to do step 1. Sometimes you're given the grams, and the first thing you have to do is convert to moles. We did that in a previous video, but in this case, we're given the moles, so we don't need to do step 1. Step 2, which we're going to do first, is use the molar ratios to convert from the moles of CO2 to the moles of the other compounds or elements. And the third step, we're going to convert from moles to grams. So as I said, we're not going to do step 1. We're only going to use, in this case, step 2, molar ratio, and step 3, converting from grams to moles, from moles to grams, using the molar mass. Okay, so let's just get started. We're going to, first thing we're always going to do is to write down the moles of the substance that we've been given. We were given moles, as I said, so we don't need to do step 1, which is converting from grams to moles. And it's good to write down the number, the unit, molar, gram, and the chemical formula. Okay, now we can convert, and we want to get out of our moles of CO2, and we want to get into, we'll do ethylene first, moles of ethylene. So we're going to put down moles of CO2 in the bottom, moles of ethylene, and then we know here, we can see here the molar ratio is 1 to 2, so we put the 2 on the bottom and the 1 on the top, and then we can cancel our units. And therefore, we know that we need 0.33 moles of ethylene. Okay, this is step 2. This is the molar ratio. We're converting from moles of CO2 to moles of C2H4, and this is what we call our molar ratio. But we don't want to know moles, we want to know grams. So we're going to use this now, and we're going to convert from moles to grams using the molar mass, put our railroad tracks down. We want to get rid of the moles of C2H4 of ethylene, so we put 1 mole on the bottom. Put the molar mass on the top, cancel our units, multiply 0.33 times 28, and we get that we would need 9.23 grams of ethylene to produce 0.65 moles of carbon dioxide. Okay, so that's the first one. We're going to basically do the same thing, of course, using different molar ratios and different molar masses for the oxygen and the water. Okay, so let's just go ahead and kind of run through those really quick. We're going to start once again with the 0.65 moles. We're going to convert using the molar ratio, and this time we're going to do the oxygen. So we have moles of carbon dioxide in the bottom, moles of oxygen, 2 to 3, 3 to 2. Cancel units, multiply across, divide by 2, multiply by 3, divide by 2. You get 0.98 moles. We don't want moles, we want grams. So now we're going to use our molar mass of oxygen, 1 mole, 32 grams. And we can cancel our units, and now we get 31.36 grams of oxygen. So in order to react 9.23 grams of ethylene, we're going to need, in this case, 31.36 grams of oxygen, which is going to give us 0.65 moles of carbon dioxide. But we also want to know how many grams of oxygen, of water. So we're going to go through, we're going to do the same thing one more time. We're going to start with our moles of CO2 we were given. Convert, not really convert, but use our molar ratio to switch that into moles of H2O. it's a 2 to 2 ratio, 2 to 2 or 1 to 1. So you can see the number of moles, 0.65 times 2 and then divided by 2, you get the same number of moles over here. Then we're going to use that number of moles to convert to the mass. 1 mole of H2O, 18 grams is the molar mass. We put the moles on the bottom because we want to cancel this moles. We want to get out of the moles of H2O. That says cancel. We want to get into grams of H2O, and we get 11.7 grams of H2O. So that is the complete problem. 9.23 grams of ethylene will react with 31.36 grams of oxygen. That will yield 0.65 moles of CO2 and then 11.7 grams of oxygen. Okay. Now we could convert this into grams, and just so we can check our masses and check our conservation of mass. The mass of these two, the products, has to equal the mass of the reactants. Conservation of mass, the mass you put into the equation, you have to get out. Okay. So I think that's the steps that you should use in our 3-step process. We used step 2, converting using the molar ratio, and then step 3, converting from moles to grams using the molar mass. Okay, so that's the end. I think that takes care of it. I hope you found that helpful. If you did, you can give me a thumbs up in the comment section below. Otherwise, thanks for watching, and we will see you next time.